Scientists have found that a thick layer of diamonds may exist hundreds of miles beneath Mercury's surface.
There may be a layer of diamonds up to 11 miles thick under the surface of Mercury.
The United States shut down the James Webb Telescope after it exposed shocking secrets NASA has been hiding about Mercury. Just as the telescope turned its gaze to the fiery planet, its sensors picked up something breathtaking: diamonds, shimmering across the planet's scorching surface. And that wasn't all. The deeper it looked, the stranger things became. Mercury's core, far larger and stranger than scientists had ever imagined, defies all our understanding of planets. Let us dive in and uncover what NASA didn't want us to see: secrets beneath the scorching surface. The United States quickly halted the use of the James Webb Telescope when it accidentally revealed something astonishing about Mercury that NASA had been keeping hidden. Mercury, a small planet close to the blazing sun, is anything but ordinary. Its surface holds surprising riches, like shimmering diamonds scattered across its harsh, scorched landscape. But what the telescope found wasn't just about gems. It was something far more shocking, a secret so profound that NASA had to stop its research. Mercury, often thought of as a dull, lifeless rock, endures the relentless heat of the sun. Yet beneath its rugged exterior lies a world full of mysteries that have left scientists baffled. The James Webb Telescope, which has captured stunning images from across the universe, turned its sophisticated instruments toward Mercury, and what it found was unsettling. It wasn't just the presence of diamonds. It was a combination of bizarre discoveries that forced NASA to take a step back and reconsider everything they thought they knew about this planet. Mercury's core is unusually massive for a planet of its size, making up nearly 85% of its entire structure. Scientists have long wondered why Mercury has such a huge core. Some believe it could be the result of a catastrophic collision that stripped away the planet's outer layers billions of years ago, leaving behind a dense core. Others think it might have formed that way due to some unknown cosmic event. But the secrets of Mercury go far beyond its core. The telescope detected an unusual abundance of crystalline formations, possibly diamonds, spread across Mercury's dusty plains. The idea of a planet covered in diamonds, shimmering under the sun's brutal glare, seems almost unreal. These diamonds may have formed from carbon-rich material under extreme pressure, creating these sparkling treasures scattered across the landscape. But the oddities didn't stop there. Webb's sensors picked up something even more puzzling: deep, shadowed craters near Mercury's poles containing ice. Yes, frozen water, just a stone's throw away from one of the hottest places in the solar system. How could this be? Scientists think the ice could have come from ancient comets that crashed into Mercury, depositing water that then froze in the shadowed craters where sunlight never reaches. Another possibility is that water molecules from the planet's interior escaped to the surface and became trapped in these cold, dark areas. The presence of ice on this scorched planet defies everything scientists thought they knew about Mercury and raises new questions about how water can exist in such extreme conditions. Then came the most startling discovery: a strange magnetic anomaly. Mercury's magnetic field isn't just unusual, it's unpredictable, almost as if influenced by something beneath the surface. Unlike Earth's stable magnetic field, Mercury's is lopsided, stronger in some areas and weaker in others. This strange behavior has led scientists to believe that there might be something deep within the planet affecting its magnetism, perhaps some unknown process occurring in its massive core. And as if that wasn't enough, Webb detected faint rhythmic signals emanating from within the planet, a pattern that seemed almost deliberate, like a coded message from deep inside Mercury. These discoveries forced NASA to reconsider everything they knew about Mercury. Instead of sharing these findings, they decided to keep them hidden from the public. The official statement was vague: technical issues, a delay in further observations. Imagine a planet bombarded by the sun's searing heat, yet hiding icy craters, shimmering diamond plains, a mysterious magnetic field, and strange signals coming from deep within. Mercury, with its icy craters, diamond plains, strange magnetic fields, and mysterious signals, is far more than the simple, barren rock we once thought it to be. These revelations challenge our understanding of the solar system and force us to rethink what we know about planetary formation and evolution. The recent findings about Mercury remind us that the universe is full of surprises, some beautiful, others deeply unsettling. Perhaps there are things about our cosmic neighbors that humanity isn't ready to face. But one thing is clear: the journey into the mysteries of our solar system is only just beginning. As we continue to explore the universe, we must be prepared for the unexpected. The James Webb Telescope has already shown us that even the smallest, seemingly insignificant planets can hold incredible secrets. Mercury, once thought to be a barren, lifeless rock, has proven to be a world full of wonders, from diamonds and ice to strange magnetic fields and mysterious signals. The discoveries on Mercury are a reminder that the cosmos is immense, filled with unknowns that challenge our understanding and push the boundaries of what we think is possible. The journey of discovery continues, urging us to delve deeper into the unknown, even at the risk of uncovering unsettling realities. The quest to unravel the secrets of the cosmos persists, prompting a reflection on our readiness to face whatever truths may emerge. An enigmatic iron heart, the James Webb Space Telescope, once hailed as humanity's greatest window into the cosmos, has suddenly been switched off, not because of a malfunction, but because of what it observed on Mercury, something far more shocking than anyone could have imagined. Mercury, a small planet often overlooked in the grand scheme of the cosmos, has consistently defied expectations. Nestled closest to the Sun in the vast expanse of space, it possesses unique characteristics that continuously reshape our understanding of the universe. Each new piece of data gleaned from this enigmatic planet reveals secrets that challenge even the most esteemed astronomers' assumptions. This celestial body, scarred by countless craters and marked by its harsh surface, remains a source of endless fascination. Every discovery peels back another layer of its complex geology and peculiar orbital behavior, unveiling more mysteries lurking beneath its sun-blasted crust. It's captivating to think that this small, seemingly insignificant planet could harbor hidden phenomena beneath its rugged exterior. One of Mercury's most puzzling features is its enormous core, which makes up 85% of the planet's total volume, dwarfing Earth's core, which only constitutes 15% of our planet's mass. This peculiarity raises questions about the planet's past. Some scientists suggest that Mercury may have once been much larger, before experiencing a colossal collision that stripped away its outer layers, leaving behind a dense iron core. The idea of such a cataclysmic event gives insight into the raw, violent history of our solar system. Adding to Mercury's mystery is its magnetic field, something very unexpected for a planet of its size. Unlike Venus or Mars, which have no global magnetic fields, Mercury has one. Although weak, it exists, and this has fascinated scientists since the Messenger mission discovered it. What's truly strange is that the magnetic field isn't centered. It's offset by 20% of the planet's radius, adding another layer of complexity to Mercury's enigma. This displacement suggests that something deep within the planet may be causing the magnetic heart to sit so off-center. In 2020, researchers discovered elements like sulfur, potassium, and sodium on Mercury's surface, volatile substances that should have long since evaporated in the sun's intense heat. These elements seem out of place, existing on a planet so close to the sun. Deep craters near Mercury's poles were found to contain water ice, an astonishing discovery for a world where daytime temperatures can reach 800 degrees Fahrenheit. In the permanent shadows of these craters, the water remains frozen, untouched by the sun's relentless blaze. This discovery is like finding an oasis in a furnace, an impossibility that defies logic. Then there are the hollows, strange, bright depressions dotting the planet's surface. They seem too fresh and too new, unlike anything else on the ancient, scarred terrain. It's as if the planet itself is shedding its skin, revealing something hidden beneath. The chaotic terrain, a rugged region as vast as Texas, also adds to the intrigue. Twisted and seemingly out of place, some believe this region was shaped by massive quakes caused by the sun's gravitational pull on Mercury's core. But what if these weren't just ordinary quakes? What if something artificial, something buried deep beneath the surface, triggered these tremors? Mercury's interior is equally as mysterious as its surface. Using data from Messenger, scientists discovered that its core is still partly molten, surrounded by a solid inner core. This is similar to Earth's structure, but much larger in comparison. Why is Mercury's core still molten after billions of years? What keeps it active? It raises the question of whether there could be an unknown energy source beneath Mercury's surface, a source we have yet to understand. Above this giant core lies a thin mantle, only about 260 miles thick. The thinness of this layer is perplexing, affecting how heat circulates within the planet. Could this explain the strange volcanic vents, the fresh hollows, and other unusual features found on Mercury's surface? Could it be the reason the heat has not dissipated, keeping the planet active for so long? In 2020, scientists also discovered evidence that Mercury might have once had an underground ocean of magma, a massive molten reservoir that shaped the surface, covering it in cooled lava plains. It's almost impossible to fathom that this seemingly dead world could once have been a place of fire, its surface roiling with molten rock. What caused it to freeze in place? What secrets lie beneath its scorched exterior? The discoveries continued in 2022 when nitrogen was found buried under Mercury's surface, a finding that adds yet another twist to Mercury's story. Nitrogen, an element that could have supported an atmosphere long ago, hints that Mercury may have once resembled Earth, with a thick atmosphere and perhaps even a climate capable of supporting life. And there, hidden in the permanent shadows of Mercury's craters, lies the water ice, untouched and mysterious. On a planet where temperatures soar to extremes, these frozen reservoirs seem to defy logic. How could they be there unless someone or something wanted them to remain hidden, preserved? The idea that there could be more to these icy craters than just water, perhaps evidence of something that once thrived there, is as chilling as it is intriguing. Mercury, the smallest and seemingly most unassuming of all the planets, has proven itself to be a keeper of dark secrets. Volcanic remnants, water ice, a misplaced magnetic field, and a giant molten core, all hint at something more. Could these clues point to a larger truth about the origins of our solar system? Could Mercury be guarding secrets that could change everything we thought we knew about the Sun and the planets that orbit it? With each new discovery, Mercury forces us to rewrite what we thought we knew. Every answer brings more questions, and each finding adds to the planet's mystique. As we look to future missions like Bey Columbo, we hope to delve deeper into Mercury's mysteries and uncover the truth. But the sudden shutdown of the James Webb Space Telescope raises suspicions. Mercury's story is far from over. It is a tale of extremes, of blistering heat and freezing cold, of devastation and resilience. With each new discovery, we must ask ourselves if we are ready to embrace the truth Mercury has to reveal. This small, sun-blasted planet, closest to our star, may yet hold the keys to secrets that could reshape our understanding of the cosmos. As we continue to explore, one thing becomes clear. Mercury's enigma deepens, drawing us ever further into its mysterious embrace. And as Mercury continues to whisper its secrets, the question remains, what else lies hidden in the darkness, waiting to be discovered, uncovering life's building blocks in the shadows? In the dark reaches of our solar system, where secrets are hidden behind layers of scorching heat and shadow, lies Mercury, a planet so close to the sun that its surface boils by day and freezes by night. But recently, something strange has been found, something that NASA didn't expect and perhaps didn't want us to know. A startling discovery by the James Webb Space Telescope changed everything. It uncovered hidden patches of frozen water, not on some far-off icy moon, but on Mercury. How could this barren, sun-scorched world possibly harbor ice? Was it really just the ice that caught NASA's eye, or something more? Soon after this revelation, the James Webb was abruptly shut down. Coincidence or conspiracy? In the dark, unending shadows cast by Mercury's polar craters, frozen patches lay hidden from the sun's reach. These areas, perpetually shrouded in darkness, held surprises beyond mere ice. Scientists exploring these shadowed recesses uncovered not only frozen water, but also organic compounds. The presence of these complex chemicals, vital for life, seemed improbable in such a harsh environment. This discovery suggested that Mercury, a planet once thought to be well understood, might conceal deeper secrets within its cold, shadowy craters. The revelation prompted a re-evaluation of what might be possible on this closest planet to the Sun, challenging previous assumptions and opening new avenues of cosmic inquiry. NASA insists these organic compounds were delivered by comets or asteroids crashing into Mercury over millions of years. But why is this discovery so important? Because it could rewrite our understanding of how life-building molecules move through the solar system. What's even more unsettling is that this isn't the first time Mercury has defied our expectations. Long thought to be a lifeless, static rock, the planet's surface is scarred with ridges and faults, evidence of ancient forces that once squeezed and twisted its crust. These fault lines, called thrust faults, were formed as the planet cooled and shrank over billions of years. But new evidence suggests that these shifts might not be so ancient after all. Adding to the mystery is Mercury's strange magnetic field. Unlike Earth's strong, protective field, Mercury's is weak and oddly shaped, almost lopsided. Scientists believe it might be generated by molten metal circulating in the planet's core. But there's something off about it. Why would a planet so small, with such a chaotic environment, still have a magnetic field at all? And what does this mean for the rest of the solar system? Mercury's magnetic field might be the key to unlocking secrets about other planets and moons, like Mars or Jupiter's moon, Ganymede, which also have magnetic fields that don't quite add up. These aren't just academic questions. Magnetic fields protect planets from the sun's deadly radiation, and understanding how they form could teach us which planets might be capable of supporting life. Mercury may not be habitable, but what if its magnetic field holds answers that could help us find habitable worlds elsewhere? Mercury's extreme conditions also make it a unique place to study how planets close to stars evolve. Without an atmosphere to trap heat, temperatures on Mercury swing wildly, from over 800 degrees Fahrenheit during the day to hundreds below freezing at night. This brutal environment has altered the planet's surface minerals, giving scientists a rare opportunity to understand how solar radiation shapes planetary bodies. Could this knowledge help us understand planets around other stars? Planets that might face the same intense heat. The shutdown of the James Webb Telescope sparked widespread speculation. Officially, the cessation was attributed to a technical glitch, but alternative theories began to circulate. Many questioned whether the telescope had captured something extraordinary, something so significant that it warranted concealment from the public. These questions have taken on new urgency with the ongoing Bey Columbo Mission, a joint effort by the European Space Agency and Japan to study Mercury up close. Launched in 2018, Bey Columbo is set to answer questions about Mercury's composition, its magnetic field, and the mysterious forces shaping its surface. But will all the answers be shared, or will they be buried under layers of bureaucracy and secrecy? Bey Columbo's findings could shed light on the strange discoveries made by the James Webb before it was shut down. The mission aims to map the minerals on Mercury's surface and take a closer look at those shadowed craters that hide ice and organics. But as we wait for these answers, one has to wonder, what will we really be told? What if Bey Columbo finds something that challenges the official story, something that doesn't fit neatly into our understanding of the solar system? Mercury has always been seen as the least interesting of the rocky planets, a small, scorched world with no atmosphere and no chance of life. But recent discoveries have painted a very different picture. It's a planet that's still evolving, still surprising us, and still holding secrets in its shadowed craters. If Mercury, the planet closest to the sun, can have ice, organics, and a shifting crust, what else might we be missing? These discoveries make Mercury more than just a curiosity. They make it a key piece in the puzzle of our solar system's history. The fact that Mercury can harbor these materials suggests that the building blocks of life might be more widespread than we thought. Mercury's story isn't just about one lonely planet. It's about how life's essential ingredients might survive in the toughest conditions, the forces shaping planets under extreme circumstances, and the mysteries hidden in places we'd never think to look. It's also about the possibility that the powerful James Webb Telescope, designed to peer into the farthest corners of space, saw something new on Mercury, something so profound it might have changed how we view our entire solar system. Maybe this discovery is so surprising that it's being kept a bit quiet. The telescope was built to study distant galaxies and the early moments after the Big Bang, but it has also been used to look at nearby planets, including Mercury. By observing it up close, the James Webb Telescope has revealed hints of elements and activity that we couldn't detect before. Imagine, this device, designed to look back billions of years, is turning its attention to a planet just 47 million miles away from the Sun. What it has uncovered there may alter how we think about the planets that orbit our Sun. The most surprising discovery on Mercury is the possibility that some form of organic material, a component that helps create life as we know it, might actually survive there. Given Mercury's boiling temperatures and the intense radiation from the Sun, this seems almost impossible. It's a planet that doesn't have a thick atmosphere to protect it and has no water on the surface to cool it down. Yet somehow, scientists think that a form of organic material could be holding out on Mercury, despite the planet's harsh conditions. This isn't just about finding certain types of materials, it's about changing what we thought we knew about survival. If organic materials can exist on Mercury, then maybe other extreme places could also support the same materials. Planets and moons we thought were too hostile, like Venus with its acid clouds or some of the icy moons around giant planets, might hold hidden organic materials too. This discovery could mean that our understanding of where life might be possible, or where the elements for life might survive, needs to expand. Mercury's surface and rocky crust have been battered by solar winds and cosmic radiation for billions of years. Unlike Earth, Mercury has no atmosphere to protect it from these forces. Because of this, it still bears the marks of its past, craters and ancient rock formations that show what the surface of a rocky planet looked like long ago. Studying these features is like traveling back in time to when planets, including Earth, were still forming. Learning about Mercury's history might help scientists understand more about how our own planet was shaped in its earliest days. And then there's Mercury's magnetic field, a mystery in itself. It's surprising because, given its small size, we wouldn't expect Mercury to have a magnetic field at all. Yet it does, suggesting that the planet still has a molten core deep inside, a characteristic more typical of larger planets. Magnetic fields help protect planets from harmful radiation. Our own magnetic field protects Earth's atmosphere, shielding life here from dangerous solar rays. Mercury's magnetic field, though much weaker than Earth's, could provide some level of protection that allows certain materials, possibly even organic compounds, to survive. But here's something fascinating. What if the James Webb Telescope has actually seen something so groundbreaking on Mercury that it had to be kept quiet until scientists understand it better? New discoveries that contradict our understanding of planets can have massive implications. If we're seeing something that rewrites the rules of planetary science, it's natural for scientists to proceed with caution. They want to study the data carefully and avoid any mistakes that might lead to wrong conclusions. If we really think about it, what else might we be missing about our solar system? If the telescope did find organic compounds on Mercury, this could spark new interest in places like Venus, or even some of Jupiter's moons, where scientists might discover similar conditions. This kind of finding would push astronomers to question everything they know about the planets and moons we've been studying for so long. Mercury's orbit and its rocky, sun-baked surface add another layer to the mystery. Because it's so close to the Sun, the planet goes through intense periods of radiation and solar storms like no other. If organic molecules can handle Mercury's conditions, they might offer scientists insight into how similar materials might survive on other planets in close orbits around their own stars. These planets are called exoplanets, and knowing more about them could expand our understanding of where to search for life beyond our own solar system. Mercury's mysteries make us look twice at this small, scorched world. For a long time, we thought of it as little more than a hot, dead rock. It's small and close to the Sun, so it seemed logical to assume it had nothing important to tell us. But if this story of resilience and survival is true, then maybe Mercury has more to offer than we ever realized. Maybe in its scars and secrets, it holds clues to survival, adaptation, and resilience in the universe. While Mercury may seem unforgiving, its burning deserts and boiling days are gentle compared to the mysteries of some strange exoplanets out there. Mercury's dark twins. These are worlds beyond the reach of our eyes, hidden away in the blackness, each holding secrets that are terrifying, mesmerizing, and almost impossible to imagine. The universe hides monsters among the stars, and here are some of them: waiting to be known. About 62 light-years away, there's a world named HD 189733b. At first glance, it might seem almost peaceful, cloaked in a rich, deep blue that would make you think of oceans and calm skies. But there are no seas here, and peace is nowhere to be found. The deep blue comes from silicate particles, but it's not a friendly shimmer. On this alien world, glass rains from the sky, not gently falling, but blown sideways by the rage of winds that race at over 5,000 miles per hour. Imagine shards of molten glass slicing through the air, carried by gales that move faster than anything the Earth has ever known. It's a storm so fierce that even the fiercest hurricanes we experience would seem like a soft whisper. In the temperature, more than 900 degrees Celsius. The heat alone is unbearable, but paired with the raging storm of glass, it's a reminder that the beauty of the cosmos can also be brutal. Mercury, by contrast with its sun-baked surface, suddenly seems almost merciful. Further across the galaxy, there is another nightmare world called Kepler 10b. This is one of the first rocky exoplanets we ever found, and it's far more extreme than anything in our solar system. If Mercury is a hot desert, then Kepler 10b is an inferno where rocks melt and metal runs like water. This planet hugs its star so tightly that the surface has become a pool of molten lava. There is no escape here. The heat from the nearby star is relentless, stripping away the atmosphere, leaving behind nothing but a blazing rock, glowing and twisting in a sea of fire. It rains molten iron here, a rain that scorches rather than refreshes. The heat on Mercury can melt lead, but on Kepler 10b, it's so much worse. A world forever ablaze, a reminder of the furious power that stars can unleash on their loyal planets. Somewhere even stranger, there lies a planet that devours light itself, WASP 12b. Unlike most planets that reflect some light from their stars, this gas giant absorbs almost every single ray. It orbits so close to its parent star that a year here passes in just over a day. On the day side, temperatures reach 4,600 degrees Celsius, hot enough to destroy anything we know. The night side, though much cooler, is still boiling. It is a world caught in darkness, absorbing light, swallowing it, keeping its secrets hidden forever. Where Mercury is bright, blinding even, WASP 12b appears like a shadow, an abyss among the stars. It's a reminder that some places in our universe prefer darkness, where even light is not allowed to survive. But not all these worlds are violent, at least not in the ways we've seen. GJ 504b is a planet that glows pink. It's far from its star, 9 times farther than Jupiter is from our sun, and its distance gives it a strange freedom. The pink color comes from its heat, not from fire, but the gentle warmth of a newly born planet still glowing from formation. Imagine looking up to see a magenta sky. Unlike the dull gray of Mercury, this world is beautiful, a strange beauty that draws you in, making you forget that you're staring at an alien world, an unfamiliar place. It's a reminder that not all extremes have to be terrifying. Sometimes they can be mesmerizing. And then there's Upsilon Andromedae b, a place of extreme contrasts. One side always faces the star, burning endlessly under its rays, while the other side knows only darkness and cold. On the day side, temperatures soar to 1,600 degrees Celsius, while the night side falls into a freezing stillness. This is a world of fire and ice, a place where day and night are divided not just by light, but by unbearable heat and bitter cold. It's a strange kind of dance, this constant battle between extremes, each side never knowing what the other experiences. Compared to this, Mercury's extremes between scorching days and freezing nights seem almost balanced. The universe is vast, and for every mystery we uncover, 1,000 more appear on the horizon. These planets are just a few of the extremes that we've discovered, places where the rules we know are twisted, pushed, and broken. They show us that while our solar system might seem harsh, there are far stranger, more terrifying worlds out there. From raining glass and raging winds to planets that swallow light and burn endlessly, these places are both beautiful and terrifying. They're a reminder of the extremes of nature, a nature that, beyond our understanding, exists in ways that challenge everything we know. And still, we search. Not out of fear, but curiosity. The search for the unknown, the thirst for discovery, drives us to seek answers to questions we don't yet know how to ask. The universe is not silent. It's alive, filled with wonders and horrors that we're only just beginning to understand. So could Mercury hold clues to life's potential origins in unlikely places? What do you think? Drop your thoughts in the comments, hit like, and subscribe for more space insights.